Hello students, today we will discuss the important topic, that is the types of enthalpy change. Already we have discussed in the last class that enthalpy change, entropy change, these are different. This is a particular type of energy change in terms of heat in a specific condition. Here condition is enthalpy change at a particular pressure, at constant pressure, that is called your enthalpy change. That is amount of heat change takes place at a particular pressure. But one thing is here, what the change takes place, whether it is a physical change or is chemical change, both changes involve the heat change. So when the heat change is measured at constant pressure, at a particular temperature also, that is called standard enthalpy change. When it is measured at standard state, standard means at a particular temperature, 25 degrees Celsius, and 1 atm pressure, that is called standard enthalpy change. Standard enthalpy change. Standard enthalpy change means condition is enthalpy change at constant temperature. Temperature is 25 degrees Celsius and 1 atm pressure. This is the condition. When it will be measured at 25 degrees Celsius and 1 atm pressure, this enthalpy change is called what? Standard enthalpy change. Generally it is measured in calorimeter, bomb calorimeter, to measure the enthalpy change. So now we discuss different types of enthalpy change, different types of process, whether it is a physical process or chemical process, how the enthalpy change takes place. It may be absorbed, it may be evolved. It may be exothermic or it may be endothermic. So let us discuss. First enthalpy change is, let it be enthalpy of formation. Delta F standard state, that is, it is formation. Enthalpy of formation. The symbol indicates the meaning. Delta F means formation. Actually here definition is that for the formation of 1 mole of substance from its elements, how much energy takes place, that amount of heat change takes place. Heat change takes place for the formation of 1 mole of substance from its elements. This is your definition, that what? For the formation of 1 mole, how much enthalpy change takes place? For example, enthalpy of formation of water, let it be, for H2G plus half O2G convert to water, here L. Here enthalpy change is standard state. Enthalpy of formation of this water is 2 minus 285.5. 85.8. It is approximately 85.8 kilojoule. This is the amount of heat produced for the formation of 1 mole of water from hydrogen oxygen. So that here important thing is you have to see the product should be 1 mole. If it is multiplied x, then you have to, that enthalpy change takes place, you have to divide the x. If it is multiplied 2, you have divided 2. As it is 1 mole, so this is called enthalpy of formation of 1 mole of water. So this is about enthalpy of formation. Then enthalpy of combustion, that is enthalpy of combustion is delta H C. Delta H C enthalpy of combustion. Enthalpy of combustion will be the same for the combustion of 1 mole of substance from its element. For example, you take carbon, then oxygen, carbon is solid, oxygen is gas, then produce carbon dioxide gas. Here enthalpy change is called enthalpy of combustion in standard state. That will be how much? Minus 393.5 kJ. You have to remember the values. It will be better for calculation. So for the combustion of 1 mole, the substance should be 1 mole. When the substance will be born in presence of oxygen forming the product, but the substance should be 1 mole. The reactant should be 1 mole. That amount of heat change takes place. That is called enthalpy of combustion. But here enthalpy of formation is the product should be 1 mole, but the reactant may be differ. Maybe 1 mole, 2 mole, that is not necessary. But the product should be 1 mole. So for the formation of 1 mole, how much reactants required you have to calculate. So then you have to multiply the different coefficient. So this is about enthalpy of combustion. This is enthalpy of combustion of carbon. Then enthalpy of solution. Enthalpy of solution. Enthalpy of solution. Enthalpy of solution. For example, we check that copper sulfate and you add water. Here water is excess, not controlled. To dissolve 1 mole, substance in excess water produce aqueous substance, aqueous. How much heat change takes place? That is called enthalpy solution. For the copper sulfate is minus, here delta H is equal to enthalpy of solution is equal to minus 66.5 kJ. This is the formation. For the dissolve 1 mole of copper sulfate in water, how much of heat change? Heat change means mainly exothermic. This indicates exothermic. Delta H negative means exothermic. Already evolved means exothermic. Absorb means positive. So this much amount is evolved during the formation of, for the dissolution of, for the solution of copper sulfate, 1 mole copper sulfate. Then enthalpy of hydration, delta H, HYD, standard state, all are in standard state. Enthalpy of hydration. Enthalpy of hydration means here to prepare 1 mole of hydrated salt. For example, you take copper sulfate, add 5 mole of water and produce copper sulfate 5H2O. This is your formation of hydrated copper sulfate, 1 mole. But required how many water molecule? 5, because the formula of copper sulfate, hydrated copper sulfate is CuSO4 5H2O. For the formation of this 1 mole of copper sulfate, how much water is required? That is called enthalpy of hydration. Here delta H of hydration will be how much? Enthalpy of hydration of copper sulfate is minus 78.2. Minus 78.2 kJ. What does it mean? That means for the formation of 1 mole of copper sulfate, hydrated copper sulfate, that is By combining 5 water molecules, the energy change takes place is -7, means this much of energy is released. But what is the difference of hydration and solution? Solution water is not fixed, hydration water is fixed. Number of water molecule is fixed, here water molecule is not fixed, but amount of substance is fixed. This is the difference between enthalpy of hydration and enthalpy of solution. Then next is 5 is enthalpy of atomization. Enthalpy of atomization. Atomization in standard state. This is enthalpy of atomization is, for example, you take the formation of H2 convert to 2H, H2G convert to 2H. In this case, H2 to 2H, it is required 435. That means how much? Here delta S is equal to 435 kilojoules. This much of amount of heat is required to break what? 1 mole of water to 1 mole of hydrogen to hydrogen gas. Atomic form. To convert into molecule to in atomic form, you take any molecule to convert into atomic form, that much of heat is required. That is called enthalpy of atomization. Enthalpy of atomization. Always here 1 mole. This is 1 mole. Fixed. Enthalpy of atomization. Then enthalpy of fusion. What is the enthalpy of fusion? Enthalpy of fusion written like this. Enthalpy of fusion indicates what? Formation of 1 mole of solid, suppose solid to liquid. 1 mole, it should be 1 mole. When 1 mole of solid is converted to liquid at its melting point, this amount of heat change is called enthalpy of what? Enthalpy of fusion. For water is how much? For water that is plus 6.0 kilojoule. This much of heat is required to convert 1 mole of ice to water. 1 mole of ice to water required only 6. Then enthalpy of vaporization. Enthalpy of vaporization means let it be H2O liquid convert to H2G. It is also 1 mole. To convert 1 mole of liquid to vapor at its boiling point, here delta H is equal to plus 30 kilojoule. This much of heat is required to convert 1 mole of water to steam, 1 mole of water to vapors. That will require 40 kilojoule. And remember, similarly here enthalpy of sublimation. Enthalpy of sublimation in standard state is equal to, let it be, you take iodine solid convert to iodine gas. Here you have to take the volatile solid. When volatile solid directly convert to gas, that is called what? That is called sublimation. Same 1 mole of solid to direct gas. How much of heat change takes place? For enthalpy of sublimation of iodine is 62.39. Your delta H is equal to 62.39 kilojoule. This much of heat is required to convert 1 mole of iodine to iodine vapors. And remember, sublimation, evaporation and fusion, there is relation. Enthalpy of sublimation standard state is equal to enthalpy of fusion standard state plus enthalpy of vaporization standard state. So remember this relation also important. But enthalpy of sublimation is the sum of enthalpy of fusion plus enthalpy of vaporization. So solid can directly, first solid will convert to what? Liquid, then liquid can vapor, but it may be directly or indirectly, result will be same. So enthalpy of sublimation is sum of the enthalpy of fusion plus vaporization. Okay, this is regarding sublimation, vaporization, fusion, like this. Then enthalpy of neutralization. Another is enthalpy of neutralization. Enthalpy of neutralization is neutralization. Enthalpy of neutralization generally it is the amount of heat produced for the reaction of 1 mole of H plus with 1 mole of OH minus forming water molecule, liquid in aqueous medium. When 1 mole of H plus combined with 1 mole of OH minus forming 1 mole of water, that much of heat produced. Here delta H is equal to minus 57.1 kJ. This is called enthalpy of neutralization. You can say enthalpy of neutralization is the amount of heat produced by the reaction for the reaction of 1 gram equivalent of acid with its base. 1 gram, you can say 1 gram equivalent of acid reacts with base. Okay, that amount of heat produced, acid with base, both having 1 gram equivalent, that amount of heat produced is called enthalpy of neutralization, or you can say for the reaction of 1 mole of H plus ion with OH minus forming 1 mole of water molecule, that much of heat is produced is called enthalpy of neutralization. But neutralization reaction always exothermic. Where the minus sign is used, that is exothermic. Where plus sign is used, that is endothermic. So enthalpy of neutralization is always exothermic. But it is observed that for strong acid with strong base, always for enthalpy of neutralization always minus 57.1 kilojoule. But if acid is strong and weak base, result will be less than 57.1. If acid will be weak and base is strong, it will be result also less than 57.1. If both are weak plus weak base, result will be very less than 57.1. So this is a very important concept. When both are strong, they produce very high ionized, so the number of H plus ion, OH minus will be more. So the amount of heat produced is always equal to minus 57.1 for enthalpy of neutralization. That means the amount of heat produced for the reaction of 1 mole of H plus with 1 mole of OH minus. But if one is weak, so as acid or base, when it will be weak, to dissociate weak acid and weak base, the amount of heat will be needed. That's why that much of heat is produced, is utilized to break the weak acid and base in water. That's why the amount of heat produced will be less. If both are weak, so amount of acid, amount of heat produced again, it will be more or less. So this is the difference. This is a very important concept regarding enthalpy of neutralization. During enthalpy of neutralization, here the amount of heat produced for action of H plus and OH minus, always minus means produced, minus 57.1. So this is, remember the difference of, for example, you can take example that suppose HCl react with NaOH, aqueous medium, producing that reaction, the delta H neutralization will be minus 57.1 kilojoule, because it is weak, it is strong acid and strong base. So enthalpy of neutralization is minus 57.1. So it depends upon the nature of acid or and base. That on the basis of nature of acid and base, the enthalpy change will be either minus 57 or less. It depends upon the nature of acid and base. So this is regarding the enthalpy of neutralization. Then we will discuss, you complete this one, the remaining part is enthalpy of, we will discuss bond enthalpy. Next is so many other examples, you finish this one, okay. Then enthalpy of allotropic transformation, okay. Enthalpy of allotropic transformation. Enthalpy of allotropic transformation. Here you can write that, for example, to convert 1 mole graphite to 1 mole diamond. Here graphite is converted to diamond. Here it is called transition. Also you can tell enthalpy of transition, enthalpy of allotropic transformation. Here delta H transition will be for this reaction is equal to plus 1.9 kilojoules. Okay. So enthalpy of transition or enthalpy of allotropic modification is called what? To convert 1 mole of allotropic form to another. How much heat change takes place? That is called enthalpy of transformation, allotropic transformation or enthalpy of transition. Here you have to see to convert 1 mole to another. Here you have to take 1 mole graphite, 1 mole. This is called enthalpy of transformation or transition. Then bond enthalpy. What is the bond enthalpy? Bond enthalpy. Bond enthalpy, that is, it indicates the formation of 1 mole. Energy change, heat change for the formation of 1 mole of particular bond. For the formation of 1 mole of particular bond. Okay. For example, take methane. When methane breaks, let it be like this. For the methane, suppose methane when first breaks, that is called delta H1, forming DH3. Then one H will be broken. Then you break another H, that is called delta H2, forming CH2. Then break another one, delta H3 becomes CH. Then break another one, delta H4, that is C plus H. So to break this bond, energy is 427. Energy is plus 427 kilojoule. To break second bond, that is 439 plus 439. To break third bond, that is plus 452. To break fourth one is plus 347. This much of kilojoule of heat is required to break first CH bond, second CH bond, third CH bond, fourth CH bond. Because methane has only 4, it has 4 CH bond. Methane has 4 CH bond. CH4 means 4 CH. To break first CH bond is not equal to break second CH bond, because when the bond breaks, then the environment, the bonded atom will have in different environment. when the nature of bonds will be changed, the nature of molecule will be changed. That's why this is called bond dissociation enthalpy. So what is the summation of bond dissociation enthalpy? How much? Delta H1, delta H2, delta H3, delta H4. This is for methane. For methane molecule, this is the summation of bond dissociation enthalpy to break first CH, second CH, like this. But what is the bond enthalpy? Bond enthalpy of CH bond. CH bond in methane will be as 4 to break 4 CH bond. This is the energy. So average, what is the average to breaks one CH bond? CH delta H1, delta H2, delta H3, delta H4 upon 4. So result is how much? If you add this one, result will be 1665 upon 4. Answer is how much is coming? That is plus 416 kilojoule. So this is the what? Bond enthalpy of CH bond enthalpy of methane. CH bond enthalpy. So what is the bond enthalpy? It is the average of all bond dissociation enthalpy. This is called bond dissociation. To break first CH bond, this is called bond dissociation enthalpy. This is called bond dissociation enthalpy. This is called bond dissociation enthalpy, like this. But what is the actual bond enthalpy? Average. Okay. So like this, you can calculate bond enthalpy. Bond enthalpy in terms of breaking of bond, that is positive side. In the formation, in the formation of CH bond, it will be minus sign. To break one CH bond, energy required this. This is the bond enthalpy CH bond to break. For the formation, it will be minus 416 kilojoule. So this is the difference. Remember, for the breaking of one mole of CH bond, bond enthalpy is much. So for the formation of CH bond, bond enthalpy is minus. So this is the difference. You can do also in this way. So this is the bond enthalpy of what? Methane, CH bond enthalpy in case of methane molecule. Then taking this bond enthalpy, we can derive another important law, that is Hess law of constant heat summation. Hess law of constant heat summation. According to this law, total heat change of a reaction is constant. Total heat change of a reaction is constant whether it occurs in one step or several steps. Okay, if it takes in one step or in different steps, total heat change, total enthalpy change remain constant. For example, you can take example C plus half CS plus half O2G convert to COG. Here heat change is for formation of carbon monoxide. The enthalpy change is minus 110.5. Delta H is equal to minus 110.5. 0.5 kilojoule. Okay, this is for what? This is for carbon monoxide. If again you take carbon monoxide G plus half O2G convert to CO2G. Here delta H, suppose this is delta H1, this is delta H2. What is delta H2? What is the value of delta H2? That is minus 283. Minus 283 kilojoule. Okay? So, carbon convert to carbon monoxide in first step. This is the first step, this is the second step. So, first step enthalpy change is minus 110.5. Second enthalpy change is minus 283 kilojoule. Here, carbon convert to carbon dioxide. What will the enthalpy change? So if you add it, so it will be CS. Then this is cancelled. Remaining O2, half O2 plus half O2, that is O2 convert to CO2. Here enthalpy change, total enthalpy change, delta H will be, here it will be added, minus 110.5, then minus 283.0. Result is minus 393.5 kilojoule. So this is the enthalpy change of the formation of carbon dioxide. So if you see like this, C convert to CO by oxygen, combined oxygen. Then CO convert to CO2 by taking oxygen. Then direct combustion of carbon to carbon dioxide. So this is your delta H1, this is your delta H2, this is your delta H, let me delta H. As per the Hess law, this is the direct step, this is the step 1, this is the step 2. Step 1, step 2. As per the Hess law, delta H is equal to delta H1 plus delta H2. All will be same. There will be no change. Direct step enthalpy change is same as number of steps. This is called enthalpy change for a reaction, whether takes place in one step or several steps. It will follow Hess law. So this is regarding the different types of enthalpy change, bond enthalpy and your bond enthalpy, then how the enthalpy change is calculated for different types of reaction, whether it proceed in one step, several steps. In next class, we will discuss the numericals related to enthalpy change. Okay, thank you.